Weather hazards come in many forms. Some are clearly visible, while others may be encountered unexpectedly. In this section, we'll look at some of the common hazards and discuss how you can avoid them. The thunderstorm is a weather phenomena which is capable of producing very violent conditions. Thunderstorms can develop rapidly, and the hazards associated with them can exist for several miles beyond the storm itself. Three atmospheric conditions are necessary for their formation. The first is unstable air, which allows for extensive vertical development. Second, there must be some type of lifting force, such as convection. Finally, moisture must be present. A thunderstorm passes through three stages: cumulus, mature, and dissipating. The cumulus stage is characterized by updrafts, which may extend from near the Earth's surface to several thousand feet above the visible cloud. Also, during this stage, water droplets form into raindrops. However, instead of falling to the Earth as precipitation, they are suspended in the cloud by the updrafts. The second, or mature stage, begins as the raindrops begin to fall to Earth. You can expect the most violent weather to occur during this phase. At this time, the raindrops have grown so large that the updrafts can no longer support them. As they fall, they pull air with them, creating downdrafts, which may exceed 2,500 feet per minute. As the downdrafts reach the surface, they spread out, creating strong, gusty surface winds. The dissipating stage begins when the cell becomes predominantly downdrafts. During this stage, the intensity of the precipitation decreases. It is also during this stage that the upper-level winds often blow the top of the cloud downwind, giving it an anvil appearance. However, this does not necessarily mean that the storm is over. Severe weather could continue well after the anvil forms. While thunderstorms usually have similar physical features, they can differ in intensity, degree of development, and associated weather. Lightning is one of the weather hazards that always accompanies thunderstorms. Other hazards might include heavy rain, hail, turbulence and gusty surface winds, and even tornadoes. As you gain experience, you'll learn how weather limits your flying. But regardless of your experience, you should always avoid intentionally flying into or near thunderstorms. To do this, you must know where they exist or are likely to develop. You can determine this by checking weather reports and forecasts prior to departure and during your flight. If widespread thunderstorms are being reported, you might find it necessary to delay or cancel your flight. If you encounter thunderstorms while airborne, you should never attempt to fly over them. These clouds can build faster than your airplane is capable of climbing. Flying below the cloud can be just as hazardous because of the extreme turbulence produced by the downdrafts. And you shouldn't try to fly around a thunderstorm unless you can maintain at least 20 miles between it and yourself. If that isn't possible, it might become necessary to turn around or fly to an alternate and wait for the storm to pass. The turbulence associated with thunderstorms varies in intensity, from light, annoying bumps to severe jolts that can damage your airplane and injure its occupants. To minimize its effect, slow to maneuvering speed or less. One form of turbulence, called wind shear, is a sudden shift in wind speed or direction. It can occur at any altitude and in a vertical or horizontal plane. Wind shear is often associated with a more serious phenomenon called microburst. A microburst is an intense, localized downdraft which descends from the base of a convective cloud. As the air reaches the surface, it spreads out in all directions, often forming in a circular motion. This circulation creates an area of severe horizontal and vertical wind shear. A wind shear is particularly dangerous when it's in the proximity of an airport. To show you what can happen, suppose you're taking off into a microburst. You would initially experience a headwind and an increase in performance. When the aircraft reaches the point where the wind shears to a tailwind, it experiences a severe decrease in performance, which could lead to disastrous results. Some airports are equipped with a low-leveled wind shear alert system, which allows controllers to advise you of significant wind differences on the field. Whether or not this system is available, any time a thunderstorm is in the vicinity, you should anticipate the presence of a microburst. While most microbursts are associated with heavy precipitation, moisture does not have to be present. They sometimes occur in virga, or streamers of precipitation that trail behind clouds and evaporate before reaching the ground. If there is no precipitation, a ring of dust on the ground, or trees being blown in different directions may be your only indications. Do not take off or land at an airport when you suspect a microburst exists. If you are in the air, delay your landing or divert to another airport. Most microbursts will pass over an area within a few minutes. Another form of turbulence occurs near mountains. It develops when the air is stable and winds in excess of 40 knots are flowing horizontally over mountain ridges. However, some turbulence may develop when the winds blowing over the ridges exceed 25 knots. If the air is unstable, the air on the windward side of the ridge will probably be extremely turbulent. If there is enough moisture present, cumulus clouds and possibly thunderstorms may develop. As the wind crosses the ridge, it spills down the leeward side. This may create violent downdrafts which could exceed the climb capability of your aircraft. If the air is stable, the wind flow will be smooth on the windward side. As it crosses the mountain, it tends to flow in layers or waves. The crests of these waves are often marked by lens-shaped clouds. These clouds are called standing lenticulars because they form in the updrafts and dissipate in the downdrafts, giving them an appearance of remaining stationary. Anytime this type of cloud is present, you should expect turbulent conditions. If you fly at airports used by large aircraft, you should be alert for another type of turbulence called wake turbulence. This type of turbulence occurs when a large airplane is generating lift and is most pronounced at low airspeeds and high angles of attack, such as when taking off or landing. Although it eventually dissipates, wake turbulence can persist for several minutes. If you encounter it as you're attempting to take off or land, the results could be disastrous. At controlled airports, controllers are required to provide minimum separation between small and large aircraft. However, you have the responsibility for avoiding wake turbulence. To ensure that you don't encounter wake turbulence while landing behind a large departing aircraft, you should touch down well before the airplane's rotation point. When making an approach behind a large aircraft that has just landed, stay above its glide path and touch down beyond its touchdown point. When departing behind a large aircraft that has just taken off, you should lift off before the airplane's rotation point and remain above its flight path. If a light crosswind is present, you should fly upwind of the large aircraft's flight path. And finally, if you're departing after a large aircraft has landed, make sure you lift off at a point beyond the touchdown point. Another weather hazard you should be familiar with is structural icing. Since it occurs only in visible moisture when the aircraft's surface is at or below freezing, you're unlikely to encounter structural icing until you're instrument rated. The major reason icing is dangerous is because it changes the shape of the airfoil and destroys its lift. It can also increase the weight of the airplane and restrict control movements. Frost is a related element that you are more likely to encounter as a VFR pilot. Like icing, it can be hazardous because it interferes with the smooth airflow over the wings, resulting in a loss of lift. You should never take off unless you have removed all frost and other ice formation. As a VFR pilot, virtually all of your flying will be done with reference to the ground. When your visibility is restricted by elements such as haze, smog, smoke, fog, blowing dust, snow, or volcanic smoke and ash, you may have problems determining your position. Fog is one of the most persistent weather hazards and is frequently the cause of surface visibilities being less than 3 miles. It can form rapidly, changing from VFR to IFR conditions in just a few minutes. Anytime you have high humidity, a small temperature dew point spread, and light surface winds, you should anticipate fog and have an alternate course of action if it does occur. Although volcanic eruptions are not a common occurrence, volcanic smoke and ash can pose an extreme flight hazard. In addition to reducing flight visibility, volcanic ash can cause compressor stalls and flameouts in jet engines. In piston-powered aircraft, it can also cause severe damage or engine failure. Ash clouds are most dangerous close to the volcano when an eruption has just occurred. This is due to the large amount of ash particles, hot gases, and dust. Because volcanic ash is highly abrasive, control surfaces can be damaged and the pitot-static system and ventilation systems may become clogged. When volcanic material is injected into a stable atmosphere, the ash and smoke may be carried long distances by atmospheric winds. The gases and smaller particles spread out and may be very difficult to distinguish from an ordinary water or ice cloud. Currently, the National Weather Service monitors volcanic eruptions through pilot reports, radar, and satellite observations. Then, by using computer forecast models, the NWS forecasts ash cloud movements and provides subsequent advisories as required. If you observe a volcanic eruption, notify ATC. However, do not jeopardize flight safety to make a report. Immediately take evasive action by turning upwind to avoid entering the ash cloud. Don't attempt to fly through or climb above the cloud. When you are safely away and you can make your report to ATC, provide the location and altitude of the cloud, wind direction, and a description of the ash cloud and eruption. As you gain experience, you'll learn to recognize hazardous weather conditions. In addition, you'll learn that with proper pre-flight planning, you can avoid areas of potentially dangerous weather before you encounter it in the air. In the next volume, we'll discuss the types of information which are available to you and how to interpret them.